Now, what about this one? Let's say they ask you to please find the general solution of this equation. So you have 6 times the sine square of x, and this is added to 7 times cosine minus 3, and you say this is equal to 0. So we need to solve this, all right? Okay. The first thing we realize is we have a quadratic equation, right? Because the highest degree is 2. Well, that's fine. But now the drawback here is the fact that we have sine as well as cosine in the same equation. And it's not possible for us to solve this equation or as long as we have sine and cosine, which are both present anyway, okay? So what we need to do here is to change. We can either change or convert sine to cosine, or we can convert. No, we can't convert cosine to sine. We can only convert sine to cosine using the identity. So we know that every time we see sine squared x, we actually see 1 minus cos squared x. And then we say, well, we still have 7 cos x, and we still have this. So now we can see that everything is now expressed completely in terms of cosine, which is nice. Then we distribute our 6, so we get negative 6 cos squared x. And then we say plus 6 plus 7 cosine x minus 3. And this is equal to 0. Then we can see that we have like terms, of course, and that is 6 as well as negative 3. So 6 minus 3 is positive 3. But then we can see that we have negative 6 that is disturbing us. Unfortunately, in this case, we cannot divide with the negative 6. Why? Because if we divide by this negative 6, we are going to create fractions. We'll have 7 over 6, and we'll also have 3 over 6, which is a half. And we don't want to have fractions in our quadratic equation. So the question is, how do we resolve this? Well, the best we can do is to divide throughout with the negative sign. So it means we have 6 times cos squared x. And then we say minus 7 times cosine. And then 6 minus 3, it's supposed to be positive 3. But since we are dividing with the negative sign, then the answer will be negative 3, okay? But this means we are actually dealing with an advanced quadratic equation, whereby the coefficient of x squared, in this case, cos squared x, is not 1, okay? Now the question is, how do you get out of this mess? You can actually simplify this equation to saying you have 6x squared minus 7x minus 3, and this is equal to 0. Well, there's actually 2 ways to get out of this mess. The first way is to use the quadratic formula in order to find the values of x, or put simply, to find the values of cosine x. And the second way is to actually use a table to factorize, the method that you learned in grade 10. And of course, there are many other methods of factorizing this equation, but I'm just going to use the one that you learned back in grade 10. So this is what you used to say. You say, okay, fine. You're going to list the factors of the first term as well as the factors of the last term. Okay. Well, the first term can be written as 6x times 1x. but it can also be written as 3x times 2x. Now, the last term can only be written as 3 times 1. So now we are looking for a combination of factors. And by combination, I mean this thing multiplied by that, it's one combination. We are looking for a combination that will add up to 7x. So if we say 6x by 3, we get 18x. There is no way these two combinations can add up to 7. The same applies if we say 6 by 3. In fact, 6 by 1 and x by 3. Well, there's no way we can get a 7 from those two combinations. Now, what about if we say 3 by 3, we get 9x. 2 by 1, we get a 2x. So we have 9x as well as 2x, which can definitely give us a 7x there. So this is how we write it. We say, okay, fine. 3x is going to be multiplied by 3. And when I multiply these two together, well, I'm just going to get 9x, all right? Then I come back and say 2x will be multiplied as well, but we multiply it by 1. And when we do, the answer is going to give us a 2x. Now, we are hoping to achieve negative 7x, right? So the bigger one takes the sign of the middle term, and this one will have to be positive. So what does it mean? It means the first factor is going to be 3x and 1, and the second factor is going to be 2x and 3. And the signs of these vectors will be positive and negative. So that's where we get the sign of the first vector. And this is where we get the sign of the second vector. But of course, you understand that x is actually cosine. So it means we have 3 cosine x plus 1. And this is multiplied by 2 cosine x. And then you say minus 3. And this is equal to 0. Then from this point, it's time for you to apply the zero vector law. For the first one, you'll say cosine x is equal to negative third, or cosine x is equal to 3/2, right? Of course, because you need to take this one to the other side and divide by 2. But of course, you know that for this one, there is no solution. Why? Why is there no solution? Well, this is because if you go to the cosine graph, this is how the function of cosine looks like. So it looks something like that, more or less. And also, of course, if you were to extend it on the negative side. But the most important thing is the lowest y value is -1, and the highest y value is 1. And 3/2 is 1.5, which is definitely greater than that. So there is no value of x, which if we substitute into the function of cosine, will give us a y value of 1.5. But of course, you'll still get a no solution if you do it on your calculator. And say when finding the general solution, you are going to say the reference angle is the arc cos of 3/2. And you simply get a math error. So, yeah. So it means our work is actually greatly simplified because we actually need to find the general solution of this part. And our happiness is complete. So now we come and find the reference angle. Well, we say the reference angle is going to be the arc cos of 1 over 3. And this is 70.528 and so forth. But since here the coefficient of x is 1, it means we won't be dividing anyway. So I can choose to say it's 70.53 rounded off to 2 decimal places right away. All right. Okay, that's fine. So now we can come and say, in which quadrant is cosine negative? Well, cosine is going to be negative in the second quadrant as well as in the third. So what is happening in the second quadrant? It's 180 degrees minus the reference angle. And of course, we need to add k times 360 degrees, all right? So if we say 180 degrees minus this answer, we get 109.47 degrees plus k times 360. And you'll say k has to be an element of integers. Okay, then now we go into the fourth quadrant. So we say in the fourth quadrant, we have 360 degrees minus the reference angle. Well, I'm not going to show that step because I'm running out of space anyway. But when you say 360 minus 70.53, you simply get 289.47. Yeah, it's 47 degrees. And then, of course, you have k times 360. And this is where k is an element of z. And you should be happy for this one. And you get all your marks. All right, sorry for that mistake. It's not supposed to be like this because it said cosine is negative in the second as well as in the third quadrant. And in the third quadrant, it's 180 degrees plus the reference angle. So when you say 180 degrees plus 70.53, then you simply get 250 plus 53 degrees. Ish. Yeah, sorry about that. Again. So here we are given that the tangent of x is equal to 2 times the sine of 2x. So this is what we have. And they tell you something important. They say, this is where cosine x is negative. Very important. Okay. So the question is, how can we find the general solution in this case? Well, here we can see that we are working with a single angle. And here we are working with a double angle. So we need to make sure that the angles are the same, all right? So in the first step, we simply say, well, where we see sine 2x, we know that we actually see 2 sine x times cosine x, okay? But then now we are going to have tangent and we have sine and we also have cosine. So how do we resolve this again? Well, we can simply say where we see tangent, we actually see sine x, and this is divided by cosine x. Okay. But then we also understand that this entire thing that we see here actually has a denominator of 1. So I can either decide to cross multiply, or I can multiply throughout by the LCD, which is cosine 5x. No, cosine x. I'm not sure where does the 5 come from, but yeah. So on the left-hand side, I'm going to get sine x. And I say 2 by 2, it's 4 there. So I have 4 sine x, but it's now multiplied by cos squared x. Do you see that? Of course you do. Now we have to take this, either this one to the right or that one to the left. What you are not going to do here, you are not going to say, well, I have sine there, I also have sine there. Therefore, I have to divide both sides by sine x and cancel it out. When you do that, well, the answer will still be right, but you have destroyed one of the solutions. So never do that. Always factorize properly and solve properly. Never divide by a variable because you're destroying another solution. Okay, so since this one has a square, it makes sense for us to respect it and keep it on the right-hand side. Then we take the sign of x to the right, it becomes negative. And we see that sine is the highest common factor. And if we take it out from the first term, we are left with 4 cos squared x. And from the second term, of course, we are left with 0. And according to the zero factor law, we have the sine of x, which is equal to 0. We also have 4 cos squared x minus 1, which is equal to 0. But since you are no longer eating milk, you are now eating solid food. It means you're going to agree with me if I say cos squared x is equal to a quarter, all right? I want you to look what is going to happen here. If you apply the square root on both sides, well, I think it makes perfect sense for me to write this one here, ne? Of course. If you find the square root on both sides, then the square root of cos squared is going to be cos x. But now what about the square root of a quarter there? Well, we are simply going to get cosine x, which is equal to plus or minus 1 over 2. But then you remember what they told you. They said you are only going to take a negative cosine. So in other words, cosine x must be equal to negative half. And these are your two general solutions that you need to solve, okay? Well, this one is a walk in a park because we come and find the reference angle and say, well, the reference angle is going to be the arcsine of 0, which we understand it's going to be 0 degrees. All right? Then we come and say sine is positive in the first quadrant. So in the first quadrant, it's just the reference angle plus k times 360. It's also positive in the second quadrant, which is 180 degrees minus the reference angle. And this will just be that. Of course, you don't forget the most important thing, the fact that k has to be an integer. It must be a whole number, which can either be positive or negative, including 0, of course. Then we come for this one and find the reference angle. Well, we say it's the arc cos of 1/2. And this is going to give us 60 degrees. And we say, in which quadrant is cosine negative? Well, it's negative in the second quadrant. And it is also negative in the third quadrant. So we can see that another general solution here will just be 240 degrees. Then it's a plus k times 360 degrees. And don't forget to add that k has to be an element of integers. And then it should be fine for this one. Well, once again, we need to find the general solution in this case. And here we are given that the sine of 48 degrees multiplied by the cosine of x, then we say minus cosine 48, and this is multiplied by the sine of x. And this entire thing is equal to the cosine of 2x. So this is what we need to solve, all right? But now here, if we give this a good look, we have sine A cos B minus cos A sine B. So in other words, they actually gave us a compound angle identity for sine. So we can now reduce this and say, well, we actually have the sine of 48 degrees minus A. In fact, minus x, I mean, because we know that this is actually the sine of A minus B, all right? And on the right-hand side, we have cosine 2x. Now the question is, where to from this point? That's a very good question. You might be tempted to convert cosine 2x and express it in terms of sine and say it's 1 minus 2 sine squared x. You might be tempted to say that. But the question is, after saying this, then where to from that point? Because think of it, how are you going to solve for this if it's now in this form? Yeah, how do you solve this? The angle here is x and the angle there is 48 minus x. Completely different angles, which cannot be made to be the same anyway. So the best you can do is to expand this, which will take you back to what you had in the beginning. So the question is, what is the best way out? Well, you're not going to write it in that way, but this is what you're going to do instead. If you remember in the first question that we did, I told you that we are going to look at, I'm going to show you how to use that 90 degrees minus, right? So this is where it's appropriate, whereby both of what we have here, both of them are positive. And of course, their coefficients are equal to 1, all right? So for this one, it's up to you whether you change sine to cosine or you change cosine to sine, because you understand that these are co-functions of one another. If you decided to change sine to cosine, on your left-hand side, you're going to have cosine 90 degrees, and then you say minus 48 degrees minus x, right? And this looks a little bit complicated, but it's still correct, and it's not really complicated at all. But for the sake of simplicity, I'm just going to say, well, I have to change cosine to sine, And I know that before it became cosine 2x, it was once sine 90 degrees minus 2x, all right? Now, this is what I want you to see. Now we can see that on both sides, we have two sine functions that are equal to each other, but the angles are not the same, right? In order for these two values to be equal to each other, that's if and only if the angles are equal to each other. So in other words, you are just going to drop the functions and you focus on the inside angles. And then you say they are equal to each other like that. For what? I want you to know that what you have on the right-hand side, it is actually called the reference angle. Okay? This is your reference angle. Very important. Okay. So now you're going to come and say, well, what is the trigonometric ratio we are working with? It's now sine. So you say, in which quadrant is sine? Positive. So you'll say, well, sine is going to be positive in the first and the second. So in the first quadrant, you have 48 degrees minus x, which is equal to 90 degrees minus 2x. And of course, you add k times 360 degrees. Then you want to collect your like term. So you take the 2x to the right, it becomes positive. You take 48 to the left. Sorry, 2x to the left, it becomes positive, and 48 to the right, it becomes negative. Negative x plus 2x, it's just a solid x. All right. 90 degrees minus 48, it's going to give us 42 degrees. And we still have k times 360 degrees, where k, of course, is an element of integers. Then we move. We say, well, sine is also positive in the second quadrant. And in the second quadrant, we have 180 degrees minus the reference angle, right? And we still have k times 360 degrees. Then for this one, we are simply going to distribute the negative sign. So we say 90 degrees will become negative, and 180 minus 90 is simply going to give us 90. The 2x will become positive, and we have k times 360 degrees, okay? Now, similarly, we take 2x to the left, it becomes negative. Negative x minus 2x, it's negative 3x. Then we come back and take 48 to the right, what it becomes negative, and we still get 42 once again. And then we still have k times 360. Then the last step is to divide throughout with the negative sign, negative 3 to be exact. So when you say 42 divided by 3, well, you simply get negative 14 degrees minus k times what? 360 divided by 3 is 120 degrees. And you don't forget to mention that k has to be an element of integers. And this is what I want to make you aware of. If you decided to change sine to cosine using the one that I wrote here and erased, it's possible that you won't get these two solutions. it doesn't mean they are wrong. No, they are still correct. You'll see that they're correct if you played trial and error, not really trial and error, but if you substituted any value of k that you like in both of them, you'll see that the values of x that you get will be exactly the same. So yes, the general solutions might differ, but both of them are equally correct. And if you said this, the marker is going to be so happy that it gives you all the marks.